Welcome back, and we are in Mathematical Language and Symbols in Mathematics in the Modern World, Part 5. So this is the last of this series this week. I hope you have understood all the things that I have discussed on the previous presentation. So in part 4, we were able to discuss the interval notations, well-defined sets, and other associated concepts related to sets. This time, let's proceed to another concept under mathematical language and symbols, how we use mathematics to make statements precise and concise using the symbols that is common in the discipline. We have to discuss set operations. So what are set operations you know? Okay, maybe you can remember the set intersection and the set union. We apply operations on sets in a manner comparable with how we apply operations on real numbers. The two fundamental operations on sets are set intersection and set union. Can you see set? Can you imagine an intersection? Yes, if it means road intersection, they meet at the middle at one point. And when we say union, oh, all people united together in one union. Or husband and wife, they become one. That's union. So let's find out how it works in set. So how the set intersection works. So given two sets A and B, their intersection denoted by A with that symbol, B is the set of elements common to both A and B. That is, A intersection to B is X such that X is element of both A and B. Therefore, it should be true that this element is element of A and this element is also element of B. Let's try to find the intersection of these sets. Given, let A equals A, B, and C, B equals B, C, and set C equals X, Y, Z, and A. Find the following. A intersection B. Okay, try to take note. A intersection B. So A intersection B is common. The elements common to them is B and C. How about B intersection C? B intersection C, is there a common element? No, so I guess B is empty set. How about A intersection C? The common is A, so C is A, the intersection of A and C. Let's try if those answers are correct. So, yeah, we're correct. A intersection B is B and C. B intersection C is empty set because there is no common element. And A intersection C is A. So we have disjoint sets. Two sets are disjoint if their intersection is empty. In the example we just did, set B is disjoint. Why? Because the intersection is empty. Now let's proceed to set union. Given two set A and B, their set union denoted by A union B is the set of elements that belong to either A or B or to both. So all the elements in A is combined to elements in B. So the elements of A combine to the elements of C and they will make the set union. So take note, A union B is equal to X such that X element of A or X element of B. Or, so it's still true if it is only true in A It's still true if it is only true in B. The intersection, it is only true if it is true to both A and B. But the set union can be true even if it is true only in one set. Okay, I hope you get that. So all elements in A and all elements of B will comprise the union of two sets. That's why if we are united, okay, all you have, all you got, that the church in union with Christ, with Jesus. So everything the church has, everything you have as a member of the church, okay, is combined with God. That's the difference. So it's not intersection, it's really union. Everything you have, you give it to the Lord. Okay? Find the union of sets. Let's have this given. Let A equals 4, 5, 7, B 6, 7, and C 1, 5, 7. Find the following: A union B, B union C, and C, A union B union C. So for the solution, we have A union B, 4, 5, 6, and 7. We don't need to write 2, 7, 2 times, because in the rule of set, when we combine sets, it should be written once only, enumerated once. Okay, B union C, the common is 7. So we have 1, 5, 6, 7. And A union B union C, the common is 5 and 7. So we have 1, 4, 5, 6, 7. Again, we write them once only. Let's proceed with the Venn diagram. Venn diagrams. Venn diagram is a pictorial representation of sets within an enclosing rectangle. Again, it's a pictorial representation of sets within an enclosing rectangle. So the rectangle represents the entire universal set U. Circles, squares, and other geometric figures represent some subsets of the universal set. Regions that overlap represent elements that are common to sets. Let's have examples. Shade the region in the Venn diagram which represents the following sets: A intersection B, B union C, A prime or A complement union C, B prime intersection C. Let's find out the solution. We will shade the region in which it represents the set, resulting set: A intersection B, B union C, A prime union C, and B prime intersection C. So, in A intersection B, which of this portion should be shaded? Okay, so I will shade it here because, okay, it's here. A intersection B. So the common is just this part. So we will shade that part. That is A intersection B. How about the second? B union C. So which part do you think? Everything in B and everything in C. So we will shade all this part of B and all this part of C. Okay, sorry for that. So this one also. Okay, so I hope you get that. So that is the part where B is united to C. Everything in B and everything in C. So how about A prime union C? Take note, it's A prime. So elements which are not in A. Again, we have the universal and A, B, and C in the circles. So which part do you think must be shaded? So it's the universal and the C. The only thing that's left is A because A union C and B is also part of the universal. Okay, so we will shade the universal. Okay, universal, 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 and union to C. C is here. Since union, everything in C. Okay, and since B is part of, okay, so kani sila must be shaded. This one, this one, this one, this one, this one, this one. But we will leave all that is A as unshaded because we have only part of, yeah, the universal set. The universal set is A prime and then union to C. So take note which part is left unshaded. We have this A because A prime man atong gamiton, and this part of the intersection it has with B because it's still A in there. So I hope it's clear. Sorry if it looks so messy, but it is how to emphasize. I just want to emphasize that this part is shaded region. Okay? So the only part which is left unshaded is the A because we are using the A prime union C. Next example. B prime intersection C. So B prime is also the universal set and its intersection to C is the common, the C only. Okay, so B prime intersection to C, we will be shading B prime intersection to C is only this one, the universal set and the its intersection to C. So only this part will be shaded. There should be no part of the B that will be shaded. Why? Because they are not B prime. We are only looking to the intersection of B prime. Okay, so this is the shaded region. You can do better than this one. So that is the B intersection to C. B prime, sorry, intersection to C. Now, let's have an example about this Venn diagram. How to use this. Apply sets on investing. Given, in a survey of 500 investors, it was reported that 270 invested in stocks, 300 invested in bonds, and 100 invested in both stocks and bonds. Use Venn diagram to answer the following. Number 1, how many invested in stocks only? 270. How many invested in bonds only? 300. How many invested in neither stocks nor bonds? Neither. How many invested in bonds? 300. In stocks, 270. But the question is, how many invested in neither stocks nor bonds? So we don't have the answer yet in the given. We need to solve it. So probably it's 570, 670, and 500. How shall I solve this? But the Venn diagram can show you that. Okay, it's the solution. We begin by filling up region S intersection B. That is the common 100. And then there are 100 investors who invested in stocks and bonds. There are 100 investors who invested both stocks and bonds. Okay, so that's why the intersection of S and B is 100. 300 investors invested in bonds. So 200 plus 300 or 300 minus 100 equals 200. And since 100 already invested in stocks and bonds, 200 investors invested in bonds only. 270 investors invested in stocks. Okay, 170 plus 100. Since 100 already invested in stocks and bonds, 170 investors invested in stocks only. So the Venn diagram shows the number of investors who invested in either stocks or bonds as 470. This leaves us with 30 investors who did not invest in either stocks or bonds. So asan yung makita ang 30 in the universal set? So that means in this Venn diagram, there are 300 who invested in bonds. There are 270 who invested in stocks. And there are 100 persons who invested both in stocks and bonds. So when we show them in the Venn diagram, we get a total of 470 here. That means out of 500 investors, only 30 did not uh, did not invest in neither bonds, invested in either bonds or stocks. So that is how to apply Venn diagram. So the last part of this presentation is to principle. We have inclusion exclusion principle. For any finite sets A and B, and A union B is equal to n of A plus n of B minus n of A intersection of B. Take note that this is the cardinality symbol. The cardinality of A plus the cardinality of B is equal to I minus the cardinality of the intersection of n of B. So, how will you find the number of elements in A union B? That is A plus B minus the intersection because we write the common only once. So that is how to find it. Given two finite sets A and B, the inclusion-exclusion helps us to count accurately the number of elements contained in the union of sets A and B. We add the elements contained in each set and subtract the elements found in their intersection. We do this to prevent double counting of elements. So answer this question. What must be true of the finite sets A and B so that A union B equals the number of elements in A and the number of elements plus the number of elements in B? Okay. Next is the inclusion-exclusion principle can be extended to problems that involve percent. So let's find out the next slide. Percent inclusion-exclusion principle. So any for all any finite sets A and B, okay, the percentage of A union B is just the same, only this time we are using the proportion of set relative to the total number of elements in the universal set. That is P of A plus percentage of A, percentage of B, and then the minus their intersection, then we can find the percentage of A union B. So that's how it works in the Venn diagram and in the counting of the number of elements when we are using the operation union. So thank you very much for watching. I hope you will answer all of the exercises properly and prepare for the quiz tomorrow. God bless everyone. Thank you for watching. Thank you for listening and happy learning. If you still have questions, be sure to send it to me before the quiz tomorrow. I hope we can answer it I can answer it today. And if there are still queries related to this um, videos or these discussions, feel free to ask. I'm not that isog not to entertain you. I just maximize my time every night so that I will not respond to your queries at night. But if you will send it during the day, I try my best to accomplish or to respond to you. So that's all for today. Thank you very much. God bless us all.